Alright, we are looking over some combinatorics today, which is the study of counting. And like many other parts of maths, it's studied mostly for the fun of it without any practical purpose in mind, although the study of counting has led us to think about symmetries and groups in a really deep way, and it's got links with group theory, which ends up being one of the most fundamental and widely used parts of maths today. So it is very useful, but it's also a lot of fun. So let's get into it. Today we're looking at factorials, permutations, and combinations. So let's start with 5 letters and think about how many ways there are of shuffling these letters around, right? Of arranging them in different orders. And the way we think about this is we give ourselves a bunch of empty spaces and we count how many options we have when we're trying to fill these spaces. So for example, if we think of the first box, we have 5 letters that could go into that box, right? And so let's say we've chosen one of those letters. To fill the next box, we now have only 4. And so we fill that box. And the next box, we've got 3. Then we've got 2. Then finally, there's only 1 option left for the last box. Okay, and so for each of those 5 options, for the first box, we had 4. And for each of those 4, we had 3 for the next one. Then for each of those 3, and so on, which means when we count them up, we just need to multiply all of those things together. So we go 5 times 4 times 3 times 2 times 1. And this multiplication sort of pattern of multiplying every number below it all the way down to 1 is very, very useful. And so we give this some notation and a name. It's called 5 factorial. And calculating this gives you 120 ways of shuffling those 5 letters together. So let's do something similar to this, except this time we'll try and only make 3-letter words. Right? By words we mean just strings of 3 letters like that, right? We don't mean actual words. So strings of 3 like this, right? So it's very similar, but this time we only give ourselves 3 empty boxes. And we do the same process. Our first empty box will have 5 possibilities, and so we fill that box. Our next one only has 4 possibilities. We choose a letter to fill that box. And our last one will only have 3 possibilities. And we choose a letter to fill that box. Okay, so it's very similar in calculations. And we multiply them, and we only get 60 ways this time. But we give this a name. It's called 5p3. P stands for permutation. And the meaning of 5p3 is we're choosing 3 things from 5, but the order is important. So CEB would be a different word to say BEC or EBC. Okay, so we're trying to make like 3-letter words using a pool of 5 letters. Okay, so one last thing. What if we didn't want the order to matter? So say we chose ABC. And we chose maybe ACB as well. What if we wanted to count these to be the same? Right? We don't really care about the order of the letters. We just want to get these groups of 3 letters. And so we're counting all of these to be the same thing. In all of these options, I have an A, I have a B, I have a C. So what if we want to not care about the order? I want to count all of those arrangements in that yellow box to be the same thing. Right, so I've got that option. I'd have a bunch of other words corresponding to A, B, and D, and A, B, and E, and so on. So how many of these boxes can I make? How many of these groups of 3 can I make if I don't care about order? Well, I guess if we, for now, remember when we do care about order, we have 5p3 options. I guess if in total we have that many, and each box contains, well, those are just all the orderings of 3 letters. That's 3 factorial. It's that many options, all right? So each box contains that many. I know in total I have 5p3 options. That means to count how many boxes, we just need to know how many 3 factorials go into 5p3. So we divide. And we get 10. Okay, so what this is it's counting how many groups of 3 letters I can choose if I don't care about order. And that's called 5C3 or 5 choose 3, and it's written in that way. We tend to use this one a lot more, so there's some other fancy notation for that. We have a big bracket with 5 on top, 3 on the bottom. It's not a fraction, don't think of it as a fraction, it's not. Okay, so that's what this one does. It chooses a group of 3 from 5 where order does not matter. So in summary, a number factorial with an exclamation mark counts the number of ways to shuffle that many things around. If I go NPR for permutation, it counts the number of ways to select R things from N things in order. So think about choosing an R or making an R letter long word from a pool of N letters. And finally, NChooseR or NCR counts the number of ways to select R things from N things where I do not care about order. So that's the difference between all of those, and I'll see you next time.